2.5, what is the scale factor?
2.5?
Yes.
So,
You dilate by what the scale factor is. So I'm telling you this is scale factor. Put it in there, we're gonna get started.
Maybe I can't find it because I said, wait. It might be the first. Somewhere down there. What is it?
No!
Mom, for me to use
Do you have it back yet? No. It may have been late. I have not graded any late portion about it.
I'm not gonna make it tonight. I'm not gonna make it tonight.
Yes, I do have that one. I did not get that graded yet because I didn't understand that word. Everyone else just came, but I know where it is, and I have a feeling. So I'll get that. What beer?
I am.
We on Friday.
Thank you. I already heard the comment from one student. I need to caution you all on this. You are not out of school on Friday. You have an e-learning day.
so we out of school.
So here's the difference. Hold on. Out of
We
school,
don't have to come.
out of school implies that you have no work or anything like that. It is an e-learning day. You should have something to do, and you will have your literacy for all essay for me to do.
Wait,
Sorry.
what about me? What about me?
Oh yeah, he's
What do you
leaving.
mean? What about you?
Cause about the time I get back, it'll be 3 o'clock in the morning on a Saturday.
Cool.
So like,
It's not due till Monday,
So you got Sunday.
and you got tomorrow. If you are going to play sports, you have to be responsible to get your academics done as well.
That's probably forced.
Not me to decide when you get it done. You have to figure out when to make it up.
I can type it.
You can type it.
Word. Finish straight.
Don't plagiarize it.
I'm
Ah.
You can't take it. Yeah.
However, I will say this: it will be impossible for you to copy this essay because I created I created what the essay is on.
When is it on?
I will give it to you soon. Hold on. Say again.
She said if it's math
No, it
related.
is not math literacy. Remember, we already did math literacy with the graphs.
Oh.
This is literacy for all, where I give you an article, and you have to write an essay in response. And we'll talk
How
about
long do it have to
it. Say again.
be? How long does it have to
Oh.
be? Is it?
We'll talk about it.
Can we smiling?
He's smiling.
It better not be no.
Yes.
2 paragraphs, 3 paragraphs.
It better not be no 2 pages. Because I ain't writing.
Wait till I get my beer.
Hey, when I put my hand up earlier, it was so that we could start class. I need your attention. So let's start going over this. A couple of quick things.
Language?
I don't know who said it, but I heard a word that we definitely should not be saying in this classroom.
Yeah. That was so
Hey,
good.
Who that was?
stop. Stop. It doesn't mean you all talk. My point, Gabe. Am I talking? If you were talking, would you be frustrated if I started talking over you? Like, you look frustrated now, and I was the one who was talking first.
That's the second time.
Okay.
That someone said that word? Or second time for what? Okay. Kaylin, can you let Terrence in? Don't be rude.
Could have closed it.
So, let's go over this bell ringer.
You got 10.
I've already talked to someone about it. You worry about you, Caitlin. Okay. So, what point is the image of 2, -5 after a 90-degree clockwise rotation? So, I have one person who said -2, 5, 2, 5, 5, 2. Got quite a few who are saying 5, -2. -2, -5. Ooh, and a lot of us saying -5, -2. Okay? So it looks like a lot of us are getting to here. A lot of us are believing that this point, dude. Like, if I can hear you breathing from up here, I know Kelsey's distracted, because that's loud, dude. Like, come on. Thank you. So a lot of us are thinking here, so we need to look at this, because that means that several of us are a little off. Close, but maybe off. 2, -5 is starting here, correct? We need to pay attention to which direction we're going to go if it is a clockwise rotation. Am I going into here or into here? So direction 1 or 2?
2.
Raise your hand with the finger of 1 or 2. So, a lot of us are thinking 2. Alright, so we're good on that. So I want us to notice, should any of these points be here?
No.
Okay, if one of you did those points, pay attention to that, because we should be in this quadrant, which that means both our x and our y are what? Negative. Well, we're going to talk about that in a second, but my point is, if we're ending up in this quadrant, my x is negative, and my y is negative. So you shouldn't have had any positive x or y values. Any questions about that? Now, the person who went here, what is actually happening if you put this point?
Reflection.
That's a reflection, right? Remember, when you multiply by -1, that's a reflection. What has to happen is what Zari was just saying. What has to happen with x and y? They have to swap or switch. So if I have 2 and -5, when they switch or they swap, I'm going to have 5 and 2, but because they're both in this quadrant, they're both negative. More and more of us are getting better at that. Hopefully that was a good recap. Hopefully some more of us will get it right next time we do this problem. Now for this next one, it says, what scale factor was applied to the pre-image? So I got a 1.69 out of 10 of us, 1.697, 1.7. Man, we are crushing it. Fantastic job overall. A handful of us missed it. Although I will say even this, 42.6 to 25.1, when I do that division, what do I get? No, 1.69, right? So how are we getting that scale factor?
Dividing
The
the
length
image
of the
and then the
pre-image.
pre-image.
I mean, the image divided by the.
Okay, so the image divided by the pre-image. Now we need some kind of length in there. I don't know if you noticed it, but I gave you the perimeter in each of those. And so it is that 42.6 divided by 25.1. I would say by the majority of us here that we're doing okay with that idea.
Yeah.
Yes?
Is my answer right?
Which one?
The one divided.
The division? Yeah, I would have, yeah, I mean, that is correct. I would have liked you to go ahead and divide it out, because that, remember, the ratio is how we get the scale factor, but when we divide, we actually get what the scale factor typically is. But could you multiply by this and get the dilation? Yes. So that would have been right. Usually, though, we don't, I guess this is the difference, and this is more just like a standard mathematical thing. We don't typically leave decimals within fractions. If I have a decimal, I'm going to go ahead and divide and get the decimal. Does that make sense? So yeah, 100% correct. And there's no reason you would have known that. I wouldn't take points off. It's just we don't traditionally leave a decimal within a fraction. Okay? All right. So a lot of us said 10. One of us said 6.25. So this one is extending what we talked about a little bit yesterday. So EF was 4, and notice it was dilated by this, and there was some confusion about it. And I will also say only 14 of us, when we have 4, 10, 14, 18, 22, 26. We had 26 students, only 14 responded. That's problematic. Yeah?
Yeah.
Put my response.
I was thinking regular.
Okay. Say again.
But then I didn't have enough time, so.
Gotcha. So, huh? So, we had 14 out of 26, I guess out of 25 at that point, but I need more of us to actually try this. This one should not have been too difficult. If you weren't sure, at least try and put something down. Now, when you dilate, dilate by a what? Scale factor. What operation goes along with that scale factor? Multiplication. So remember, the scale factor is calculated by a ratio, right? The scale factor is calculated by a ratio, but what are we doing with the scale factor? We multiply. Okay? So what is so I'm starting out with 4 for the length of EF. What is my scale factor? 2.5. If I dilate by that 2.5, that means I am scaling it by 2.5. So E prime F prime is equal to 10. We good? Matthew, you good? Darian? Make sense? Anton?
Wait. Oh, no.
You good?
Yeah, I saw that you.
What are you not good with? Brandon, you good? Josh?
Yeah.
Jordan? By the way, let's get our hoods off. Gabe, Amari, Jordan. Y'all know how this works. Alright. Really quickly, I'm actually going to finish the TI Inspired lesson on dilations first to understand the relationship between dilations and congruence or similarity. That's what we almost finished up yesterday, okay? But we didn't quite finish it. I am at some point going to give y'all some time to work on the, what is it called? The literacy for all, but I haven't decided exactly how much time you get on it. It depends honestly on how well we work moving forward. If y'all are working well, I'll give you a little bit more time to work on your literacy for all in class to make sure you understand what's happening. Okay? Pay attention. It's really hard to pay attention and write notes down with that in your hand. Put it away. This ain't no beauty class, it's a math class. Alright. We'll come back to this. Alright, so we want to calculate or identify scale factor of a dilation. We seem to be doing pretty well with that. We also want to explain what it means for dilated images to be similar. What objective have we still not covered?
Similar.
Yeah, what does it mean for them to be similar? Hey gentlemen, why don't you
They're not exactly the
Somewhat
same,
the
but
same.
they're similar.
Okay,
Not all the way.
so
Exactly.
Kaylin, then tell me and I will take care of it. Terrence? Terrence. Terrence. So, here's the thing, and I need you to hear me very clearly on this. Y'all have heard the word similar before in context outside of math. However, it is kind of similar to what you've heard similar be in the past, but in math, the word similar has a very specific definition. So we're going to look at that today, and we need to clearly understand it. Alright, yesterday I believe we did 8 and 9 and 10 here, correct? Please go ahead and get this sheet out. Jalen, get this sheet out. I get it, but you're about to have 2 days off at least one day we're not supposed to have off.
Wait, so what happened to work come here? On Friday.
Ain't nobody gonna be here.
As far as I can tell, Terrence, why are you talking over me? Anton, why are you talking? No, it's okay. I'm trying to talk. Pay attention. Kyson, Gabe, why are you talking over me? Stop. Listen. Okay. As far as I can tell, the biggest reason why we have an e-learning day on Friday is there are 16 different teachers who are somehow affiliated with the football team. There are several other teachers who have kids on the football team, and in total we're going to have roughly 30 teachers out. We don't have enough subs for all that. So they decided to make it an e-learning day because of the football game. And that allows people to go to the game. How many of y'all really drive 4 hours to go to a football game? Me? Y'all straight wild. Alright. Alicia. Austin. Terrence. There. It's time to stop talking. It's time to pay attention. Rose. Okay. As a quick recap, because I do realize there was some confusion about this yesterday, and that's partially my bad, and I apologize for this, but fundamentally we got to know this. You should already have this note down. How is this scale factor related to the ratio of length for the image to the pre-image? What you got for us, Ren?
I had the ratio.
You should have it written down.
I do.
What does it say? There are many different things. Just give me one of the things we should have written down.
R stands for scale factor.
Okay, so R stands for scale factor, right? So we're going to use R to represent our scale factor. Matthew, give me one other thing.
The ratio is how we calculate scale factor.
The ratio is how we calculate scale factor. One last thing, Rose.
The ratio is the length of the image divided by the length.
Okay. Ireland, Austin, seriously. Come on, focus up here. Dude, there's pencils up here. Come get one. No, don't even get one. Come get one.
Wait, why I gotta go over there?
Because I'm tired of you interrupting class by talking with other people that, not you, let me clarify, sorry, let me say this the right way. I'm tired of you, students, interrupting class to get pencil from someone else when I have free pencils up here. Along with erasers that you can put on the top, which magically seem to just disappear. Like, there's only so many things I can buy for the classroom. Y'all keep wasting resources on quit buying stuff. Like, grab an eraser if you need it, but come on, they should stay with the pencils. I have maybe, I don't know, 10 pencils gone. I've got roughly 40 of these things gone. That doesn't make any sense. Okay. So, yes, the R is equal to that ratio of a length from image divided by length from pre-image. That's how we calculate it. But I also want to remind you, if they are equal, that means the scale factor is that ratio, right? You calculate it through that. And we made one other note, I believe, that you multiply the scale factor by the pre-image to get the image values, right? All right. So did a triangle TRY and T prime, R prime, Y prime have the same orientation? Very much so, right? It stayed in the same exact order. It was just, what would he call it when we made it bigger?
Stretch.
Stretch, for when that dilation makes it bigger. And by the way, what value for R is a stretch? When R is what?
Greater than
No,
Greater than 1. Because if you multiply by something bigger than 1, it's going to make that number bigger. So when you multiply by something larger than 1, it is a stretch. When you multiply by something less than 1, or really between 0 and 1, it's a compression, okay? And then this is the most important part. This is the very end of class, so I'm going to rewrite this in case you did not get it. What is preserved? By the way, it's not translation. This should say, oh, it does say this on yours, right? Dilation?
Yeah, it say dilation.
So it is supposed to say dilation. I fixed it later. But what features are preserved?
angle measure.
So angle measures were the same.
Orientation.
Orientation was the same.
Shape.
The shape.
And the shape was the same. So if you don't already have that down under what is preserved, those are the things preserved, and that is important to recognize. You should have the same shape, you should have the same angle measures, you should have the same orientation. So what is not preserved?
Side lengths.
Side lengths,
Area. And area. Perimeter.
area, bless you, and perimeter. I want you to notice there is one single word we could use to describe all of this stuff. Does anyone know what it is?
No.
It's another S word.
Similarity.
Strategy.
Something.
Size.
Oh wow.
Right? Everything but the size of that shape is preserved. The size is not preserved, so the side lengths are different lengths. The area is different, and the perimeter is different, right? The size is not preserved. Jordan, that's not going to help you because you actually need that sheet. Like, no, you need that figure as it is to understand an important part of dilations. Okay? Okay, from there. So I want to talk about this number 11 because this is actually something important to understand about dilations that that we haven't really covered yet. A dilation doesn't just magically make those side lengths bigger or the area bigger. Okay? A dilation is always in respect to a point of dilation. So here's my point of dilation, right? I marked it on here as a point of dilation. From that point of dilation, I want you to notice something, right? It says paying attention to the lines that connect the pre-image point to the corresponding image point. What do you think the scale factor is? So some students are having trouble with this, and I want to point out, you see all these side lengths here?
Yeah.
Those are all for the image. None of those are for the pre-image. So you cannot figure out the scale factor based on those things. What I am talking about when I say pay attention to the lines that connect the pre-image point to the corresponding image point, I'm talking, for example, about this line right here. That's a line, right? Okay? So if I want to find a scale factor, what do I need in the numerator?
The
image.
length of the pre-image.
I need a length
length of
from the what?
Image.
Image. And then length from the
Pre-image.
And so when I look from the point of dilation to B prime, how long is that?
3 squares, but so I guess
What is the length from the point of dilation to the pre-image point? 1. So what is my scale factor? 3. Okay.
Wait, I'm confused.
Hold on 1 second. Let me finish writing this and then I'll answer your question.
On what?
Okay, what's your level of confusion?
do not say everything.
Okay. Sorry. To show the distance from the point of dilation to B.
Wait, why'd you pick this? Why'd you pick that?
Well, so remember, I need a length from the image to a length from the pre-image, right? So all I've done is I've looked at those two lengths for now. I'm not done.
Wait. No, which one is? Never mind.
Ask a question. What is what?
I don't know which two triangles I'm looking
See, that's the issue. We're not looking at the triangles.
at. Okay, where's the pre-image and where's the image?
here
A little one? Pre-image.
is my pre-image. That's my pre-image. Notice how it's B, E, D, C. That's the pre-image. Or you can do B, C, D, E, I guess. Notice here is my image. I am sorry that wasn't clear, but that was a good question. Ask your questions. But notice how it's B prime, C prime, D prime, E prime. So that's my image. Okay?
Those other ones are confusing. What are those for?
So that's what I'm talking about right here. Paying attention to the lines that connect the pre-image point to the corresponding image point. So you see how this line
Oh, that's
connects from the point of dilation through the pre-image to the image. There's an important reason why I'm pointing this out. Okay? I'm not saying it was easy to see at first, which is why I'm not going over this. Okay? But do we see that line there that's connecting the point of dilation, goes through the pre-image to the image? Yes. And what scale factor do we get out of that? 3. I can also do that here horizontally. What is the length from the point of dilation to that image point?
6.
And what is the length from the point of dilation to the pre-image?
2.
And so what scale factor is that?
3.
So what is my scale factor? 3. And this is how a dilation actually works. A dilation doesn't just take each of these pieces and make it bigger. What it does is it takes the length from the point of dilation and multiplies that length by the scale factor. So make a note to yourself here. A dilation takes the distance from the point of dilation, distance from the point of dilation to each point in the pre-image, and then what are we doing to that distance?
Divided.
Multiplying it by the,
Yeah, okay.
you're thinking about the ratio. But notice to go from the pre-image to the image, I multiply by the scale factor, right? So a dilation takes the distance from the point of dilation to each point in the pre-image and multiplies by the scale factor to get the image. That is a small but important technical part of the dilation. That's what's really happening to get each of those. I'm going to go back to what we saw in the calculator to show why that's important. Okay? Because it was a detail that probably a lot of us missed, which is why I want to talk about it here. Now, when you multiply each of those distances by the scale factor, does it also cause each side length to multiply by that scale factor? Yes. Okay? So I want you to notice, right, this is technically what's happening is I'm taking that point of dilation, I'm multiplying that distance of 1 by 3 to get, boom. But what that's also going to do as a result is this image length is how much bigger than the pre-image length?
3.
3 times as big. Okay? That's what the scale factor is. So it is multiplying the distance from the point of dilation, but it's also going to end up multiplying each of those side lengths. That's actually a detail that I use the calculators, the activity that I created with y'all, or for y'all, I use the calculator to verify that that was true every time. It took me time to do that, but it was an important component of these transformations. And so I want y'all to hear me very clearly on this. This was a detail that I thought I heard somewhere in the past, but I didn't just Google it. I took the time to explore it. I know it's different asking you to explore and to pay attention to patterns, But now that I've done that, I'm going to remember it way better than if I just Googled it. That is why I ask y'all to explore it. It's difficult to think like that, I get it. But it's going to be better for you long term. So, really quickly, I do want to go back to the calculator stuff that we did to verify this. Do what? You good over there?
No.
Okay. So I want you to look at this 1.2. Do you see this point in the center there? Ooh. Y'all cannot see that well. Y'all see that point in the center there? Yes? We good with that? So notice when I move, well first off, notice the point of dilation is here, my pre-image is here. You see how the image length is right there, or image point's right there? Yeah? And notice how my scale factor is what? 2.5?
Yeah.
So there's the distance. If I double it, it would put me to here. If I do another half, it gets me out to there. Right? That distance here was multiplied by 2.5 to get my image value. Alright? Same thing here. You see that pre-image point? Then you see that pre-image or the image point? If I take this distance and I multiply by 2.5, I get out to here. That's what's actually happening. So watch what happens when I move this point of dilation. When I move that point of dilation out to here, you see that distance here? If I multiply by 2.5, I get over to here. You see how there's a clear line segment that is connecting and it's taking that distance and multiplying. Same thing over here, I just can't see it. If I take that point and I look at that distance and I multiply by 2.5, I get up here. That's what's actually happening, which is what's causing the side lengths to then multiply by 2.5. Brent's like, yeah, that makes sense. Did that cause more confusion for anyone, or so that we have questions? More confusion but no questions? Okay. Okay. Not sure at all? Okay.
I'm good. I understand.
One thing I will show you to verify that everything I told you is not just a load of crap. I'm going to show you a measurement length. Alright, so you see how that length between the point of dilation and the pre-image is 1.29? Right now, what is my scale factor?
1.29.
My scale factor.
Oh,
2.5.
2.5. Please pick up your calculators. What am I going to do to that length in order to get the length to the image point?
Multiply by 2.5.
So multiply by 2.5.
So 1.29.
That 1.29,
Alright.
3.225.
3.225?
Yeah.
Yeah?
Big brain.
3.22.
3.22. That's
You
just
said
round.
3.25 or you said 3.25?
Okay?
225.
That's before you round it. He said
So-
you round it.
Is what I told you true? Is it multiplying by that scale factor?
Yeah.
Yes. Okay? And so that's what's actually happening. And so when you move that point of dilation around,